This is a demonstration of the Forrest Manufacturing Model 214 fitting saw. Today we're going to use it to make some trapezoidal workpieces for our customer. This is a demonstration cut. We're working with a high density polyethylene foam. And this is the shape the customer wants to make. So a trapezoid, 13-degree angle both sides. To do that, we're going to use the Forrest Model 214 saw. This is a tilting head saw. It's one of our two tilting head saws. This is a very basic machine, but much like anvils, hammers, and knives, basic machines can still be very useful tools. The way this tilts is there is a pivoting pin or bolt about in this line down here underneath the table, and you adjust the angle with a simple screw and hand wheel over here. Turn the hand wheel down, head goes up. The disadvantage of this system is because the center of rotation is below the table, as you tilt it over, the point where the blade crosses the plane of the table walks over. So for vertical cuts, this is a traveling table saw. The table travels and the blade runs down the middle of the slot. If you want to make a tilting or angled cut, we have a way to lock the table into the center position, so I can't move the table right now. And then we have a notch cut out in the center here, such that as the blade walks over, it walks over into this notch. So it's a very simple system, very reliable, and very useful, cost-effective. Pretty much all of my installation fabrication customers have something between 1 and a dozen of these machines working for making special fixtures. But today we're going to be cutting foam. So I did a cleanup cut first, just to prove the process to myself. And now I'm going to flip the workpiece back and forth and make a bunch of cuts to make these shapes. So I'll be sliding the workpiece across a fixed table to make these cuts. I've set up a workpiece fence here. It's a T-square. It's part of the standard package comes with this saw. Note about setting up the machine. This application is a great candidate for our precision workpiece positioning fence, where you turn a crank, the fence moves over, you have an electronic digital readout. Those are great fun, a little expensive. For this, I use my trusty scale and a protractor to set the angle. Like I said, it's rather basic, but like hammers, anvils, and hand knives, it works. Also on the blade, today I was using a 1/2 inch wide, 3 tooth per inch blade. It's a fairly coarse blade for cutting this. I've tried finer blades just to experience what we get, but the cut edge I got earlier with this blade is quite nice. So the material is not as sensitive to the blade as I thought it would be. There's just a little bit of fuzzing and roughness to the surface. It's not as smooth and crisp as was with a 14 tooth per inch blade, but I'm thinking it's still suitable, and it cuts a little quicker. So I'll zoom in a little bit here for you. Try to zoom in. There it goes. So start the saw. Extract the workpiece. Flip it over. Run another one. This would be so much easier with a traveling table saw, but I don't have one of those sitting around right now. We do have traveling table models, like I'm thinking of the specifically the model B2, but I only build those to order, and I don't have one on order right now. Although I think the owner of this material is an excellent candidate for the Model B2. And that's what you get. I should have, so we've got 4.83 across the bottom. Oh, my fence moved. Oh, I didn't set my fence quite correctly. Like I said, this is a great application for a precision fence. That's the idea.